Welcome to day one of our Alaskan Gold Mine expedition.
I'm Jim Bob.
I'm Jedediah.
And I'm Jeremiah.
And we're not related. On a more serious note, we're going to be looking for some special rocks that contain gold in them today.
Yeah, we're going to be looking for igneous rock, sedimentary, and metamorphic.
Wait, Jim Bob, how are we going to know if there's gold in the rocks?
We're going to mine the rocks first, then we're going to take them back to the shop, freeze them, and when they thaw, we're going to crack them open and see if there's gold in them.
Wait, isn't that a type of weathering? Freezing and thawing?
Yeah, that's the process by which rocks are broken down. Hey, I think I found something.
That's basalt, an igneous rock.
Wow. Wait, it's an igneous rock.
An igneous rock is formed by magma, which is molten rock found beneath the Earth's surface. The magma can cool either below or above the Earth's surface. When the magma cools quickly, the rock looks shiny and glass-like. Sometimes there are gas bubbles trapped beneath the rock. That's what gas is from. Hey, what kind of rock is this?
I think that's a metamorphic rock.
Maybe that's. It's not a metamorphic rock, you idiots. This is a white boy boot. This is a metamorphic rock.
What's a metamorphic rock?
A metamorphic rock is a type of rock formed beneath the Earth's surface due to intense heat and pressure. Metamorphic rocks have ribbon-like layers and can sometimes have shiny crystals.
That's so cool!
Metamorphic rocks are extremely dense, just like you guys!
Hey! I never seen this type of rock around here before.
This is a sedimentary rock.
What's that?
A sedimentary rock is the rock that is formed by the different layers of sand, shells, pebbles, and other materials. The sediments gather in layers over a long period of time and eventually harden into rock. Sedimentary rocks crumble very easily, and you can sometimes see the pebbles, stones, and sand in the rocks.
Thanks for joining us on the first day of our Alaskan Gold Mine expedition. Tune in next week when we learn how to wrangle a gator.
And I teach you how to flip a mud pancake. I'm Jim Bob.
I'm Jedediah.
And I'm Jeremiah.
And we are not related. And I'm from the Canadian National Mining Society.
Hi, Jim Bob.
Today I'm going to be telling you guys a very special story about something called the rock cycle.
What's a rock cycle?
Just wait and see.
Chapter 1. Weathering and Erosion. Once upon a time, there were 3 rocks, named igneous, sedimentary, and metamorphic.
I am magma that is cooled and hardened above or below the Earth's surface.
I'm sediment that has been compacted and cemented together to form a rock with different types of layers. I'm all types of rock that have been altered due to tremendous heat and pressure below the Earth's surface.
One day, igneous rock was chilling in the desert when she realized the wind was picking up. Over a long period of time, she was eroded away into little bits called sediment. This is an example of wind erosion, which is when wind erodes, transports, and deposits sediment from existing rocks. In the northern Canadian Shield, metamorphic rock was chilling on the side of a hill. In this part of the world, the temperature hovers around 0 between day and night. During the day, the sun warms the earth to a temperature above 0, and it falls below 0 at night due to the lack of sun. When the water isn't frozen during the day, it seeps into rocks like metamorphic rock, and at night it freezes, breaking the rocks apart. This is called frost shattering. In southern Ontario, sedimentary rock was chilling in a forest clearing, completely exposed to the elements. As it began to rain, she was becoming weathered. This happened many times, as it rained a lot where she was situated, so she eventually was eroded into sediment. This is an example of water erosion.
1. Go outside and find some rocks. Hey look, a sedimentary rock.
Identify your rocks as either sedimentary, metamorphic, or igneous using masking tape and a permanent marker. So first, write the type of rock on a piece of tape. This rock is metamorphic. Rip off the piece of tape and stick it on your rock. Then assemble it with eventually all of your other rocks in a margin tub or plastic container in preparation for freezing. Fill your container with water until the rocks are submerged, which I have already done. Put the lid on and place it in the freezer. Rocks were left to freeze overnight, and I just took it out. And there they are. Now I'm going to leave them to melt and then refreeze them
Rocks
again.
have been thawing for about 6 hours after I took them out of the freezer, and I will repeat this thawing and freezing process about 4 or 5. So I've just taken these rocks out for the last time after 5 cycles of freezing and thawing, and here are the results. So first, the igneous rock. This was the rock that we started out with, and this piece broke off, so just a little bit. Same with the metamorphic rocks, these 3, and the pieces that fell off are also very small. And however, the sedimentary rock, as you can see, is completely broken up after the experiment, also this one. And this is because sedimentary rocks are significantly less dense than metamorphic and igneous rocks. So as the water seeps into the sedimentary rock during the thawing period, and then when it is frozen, it expands because water expands when it is frozen. This pushes the pieces of the rock apart, and because the sedimentary rock is less dense, it was affected much more than the other 2 types of rocks. This is further because sedimentary rocks are made up of layers of organic or inorganic material, and these layers are compacted and cemented through erosional methods, and this creates a less dense rock versus metamorphic, which is created from intense heat and pressure under the Earth's surface, and igneous, which is cooled and hardened magma. So those are both very dense rocks, whereas sedimentary made up of organic material, and so this makes a less dense rock, which is more easily eroded and broken up through processes like frost shattering. So rocks can be broken up outside through the method of freezing and thawing, because in urban centers, in periods like early spring and late fall, when the temperature is hovering around 0 in like Toronto. So during the day, during these parts of the season, the temperature goes above 0 in the morning and during the day when the sun is out, and then falls below 0 at night because it is colder. So this allows the water to thaw during the day, seep into the asphalt in the roads, and then at night it freezes, expands, and causes the roads to crack. This is a major issue for urban centers like Toronto that are located at a higher latitude and that have 4 seasons and a temperate climate. And these examples of freezing and thawing outside can be seen, it can be reflected in this experiment, our experiment, because the asphalt is, just like the sedimentary rock, a less dense material that is easily broken up through the freezing and thawing of water. So it is affected more in rocks that are less dense versus rocks that are more dense.
That's fantastic! Are we starting?
Yeah, we were.
Hey, what kind of rock is this? I think that's a metamorphic rock. Exactly. No, you idiots. This is a white boy boot.
What is that? Rock cycle. I thought you were going, yay! I'm gonna throw something.
Sediments? Stop! No!
She's looking at the camera like, don't look at me! It's still going.
shells, pebbles, and other materials. Sometimes I forgot my line.
Elsa, what are you doing?
We can read it. We can outside go.
Oh, don't do it.
Yeah. Oh my god.
Stop barking. Rocks can be broken up like this through freezing and thawing in the real world.
Joining us on our first day of our Alaskan Gold Mine expedition. Tune in next week when we.
I didn't say the whole.
Oh, hell no!